Has there ever been a time in recorded history where one of these flares or ejections has affected Earth, or maybe something in, like, there's an event documented somewhere that thinks, maybe this could have been something?
Yes, so we actually have solar flares quite
Okay.
often. So during solar minimum, those 11 years, um, solar flares happen almost 2,000 times during that
Okay.
cycle, but they're not very
Right.
strong. You see them, they're not really impactful. The other 11 years, which right now we're almost at the very maximum,
Excellent.
in the middle of
Yeah.
2025, is going to be at the very um, peak of that solar
Okay.
cycle, which means that there are a lot of active regions on the sun right now. So just 2 months ago, there was one of the strongest solar flares we had seen over the past 20 years in May. And that's the article that you're
Right.
referring to. So we had the X class solar flare taking place on the sun. And with that, there was that solar or coronal mass
Yeah.
ejection, so that all of that charged particle also came outward with that solar flare. So we saw within 8 seconds that there was a giant solar flare. And luckily, because solar flare is just light and it's very high energy, meaning that it's X-ray, as soon as it reaches the day side of our planet, the atmosphere just absorbs that light.
Okay.
So there are consequences with that I'll get back to. But in terms of like us on the surface of the sun, we don't have to worry about the flare
Okay.
itself impacting the radiation
Right.
impacting us. However, there are two things now. One is, so the atmosphere, the day side, just absorbed all of that X-ray. What
Hmm.
happens? So when you in the lab or anywhere else, you um, shine X-ray on any neutral particles, they absorb it, and that's when they start to break down into ions and electrons, so charged particles. So neutral particle becomes charged particle, which means that when you have so much of it, now you have electric
Right.
current. And we use the top layer of the atmosphere, we call it the ionosphere, because once you have the air, you go above that, there's a lot of sunshine that is being absorbed, and that's breaking down the atoms into electrons and
Okay.
ions. And we have a whole current system, that there's a whole sphere around our planet that is conductive. And that's how, back in the day, for the first time when we started our communication platform, that we no longer were communicating via wire, the way it worked is that we would send radio waves to that layer, we call it the D
Hmm.
layer, and that would get reflected because it's a conductor. It gets reflected where you want it. And that's how we communicate across the ocean.